We just talked a little about attitudes and motivation and getting their attention and making science seem like something that's fun or cool. But I want to talk a little more about understanding and, introducing new concepts. I hate giving definitions. I always prefer to give a pattern, make them observe, and infer the definition themselves, to deduce the definition. So we'll go through a few concrete examples to see what I'm talking about. Could someone please tell us one object in this room that's made out of atoms? Okay? I don't want to hear more atoms. Just one object. This time I'm going to ask for hands raised. Jeffrey? You think the balloon rubber is made out of atoms? Okay, you're correct. Pretend you're students. Let's hear one other object. The laptop? Which was the laptop case? Okay, definitely. My laptop is definitely made out of atoms. John? These red chairs that you're sitting in? Correct. Yes, made out of atoms.
A shoe.
A shoe? Something in this room. You need to show me a shoe. You got a shoe? Okay. Yes, your shoe's made out of atoms. Okay, anyway, you guys, we all know atoms make up all material, right?
Yeah.
But the way I like to introduce it with kids, you could just say to them, hey guys, atoms are this thing, write the word on the board, A-T-O-M-S, and they make up all material, everything around us. And maybe that'll interest a few kids, surprise a few, but much better to start with a pattern. And they're going to start to notice something, right? Noticing patterns is an essential skill in science, but also problem solving in general, right? Looking at the physical world, I mean, this is how all science was developed, and noticing patterns. So, what they start to notice, I usually do at least 10 kids, right? And they've never heard of atoms, or a lot of them haven't, or they don't know what they are. So they're really reluctant to guess. And you make them. You know, I try not to get mean about it, but sometimes a kid, understandably, has no idea what an atom is. And so I get to a point where I'm saying, name an object in the room. Any object. Just name one. And the kid says something. And then I go, you are absolutely correct. How did you know that? And the kid goes, wow, I was lucky. I just guessed something. It's made out of this thing called atoms. That's one of the chances. Go to the next kid. Same thing. 10 times they start to notice the pattern. I'm not saying no to anything, no matter what their guess is. So one of them shouts out, or one of them raises their hand, and everything, all material, everything you can touch. So I think that's a much better way to get the concept across than just telling them. Atoms make up all material. So another example is, okay, once we've gone through atoms, talk about elements, we get to something else. And we could just tell them what molecules are, right? We could say, kids, molecules are multiple atoms bonded together. Instead of doing that, this is how I like to do it, okay? I draw, or I have on a printed piece of paper that groups can look at together. You know, you got 50 kids, could you print 50 pieces of paper? Maybe, depending on your resources, but you can also make it work with less resources. You could have one per group of 3. Or you could just draw it on the board and have them discuss from that. Or you could draw it on the board, they have to copy your drawing on their loose leaf, and then discuss. Anyway, what's the drawing? The drawing is, something like this. I usually give them 5 to 7 choices. And we've talked about atoms by this time. We've talked about their shapes. Okay, they're round little balls, and we've imagined zooming in on them. And I say, okay, kids, these balls are atoms. And right now, I'm going to tell you something. I'm going to use a word that you've never heard before, or you are not familiar with. And just listen carefully, kids. And maybe you just have it written on the sheet for them to follow along, or maybe not. This is not a molecule. This is not a molecule. This is a molecule. This is not a molecule. This is a molecule. And then you ask the kids the question. What is a molecule? Think individually to yourself for 1 minute. You don't need a ton of time for this, maybe even 30 seconds. Then talk to the person next to you, or the two people next to you, and discuss what you think a molecule is and why, based on this pattern. They're going to talk. Even the kids who aren't interested, they're going to be forced to talk by their classmates, okay? They're going to get engaged, and most of them are going to get something close to the right answer, right? Yeah. A molecule is multiple atoms bonded together. They're just looking at examples, making observations, and detecting patterns, right? Yeah. All right, so that's another concrete example how I like to introduce concepts. This is just a simple decomposition reaction. Then we have the kids draw the molecules, all right? They've learned about chemical formulas already. They should be able to take the chemical formula and guess what the molecule actually looks like, okay? They draw the molecules on their sheets. You're doing it on the board. And then you have them. You can do this in stages. First, you can ask them, what do you notice about the number of atoms on each side? Okay? They're going to count. And it's small and short. And what have I done wrong here, guys? What's wrong with this reaction as written? Right. Okay, then you have the kids build the molecules, right? I'm going too fast. Then you have the kids build 2 of these, blah, blah, blah. They count the number of atoms, and what do they notice? Instead of you telling them that chemical reactions do not destroy or create atoms, that atoms are conserved, right? They notice. They count 4 hydrogen atoms and 4 oxygen atoms, and the same on this side, right? And first you have them count the overall numbers, total atoms, they notice those are the same, then the individual elements. You do this step by step, okay? I'm just running through it. But once again, noticing a pattern leading to a definition with a simple example. And if you try to do this with combustion, with gasoline, or just a more complicated thing, it's just going to take longer to get the same point across. But if you can use a simple combination, or flip it for a synthesis reaction, I find it really, really sticks with that.